our next step here is going to be, let's look at doing this a little bit more accurately. So while this is all well and good, we do have the issues of, it's super malleable. We can kind of, move it around wherever we need it, but it's not necessarily super accurate. So here is another alternative that we could possibly use. And it may take us into, actually, do I want to do that another day? Well, let's start going down this road, and then we'll see how long it's going to take for us going this path, and we'll see about maybe pushing the assignment to next week, or maybe we can finish this up next week, and I'll give you the assignment this week. So the new method here is going to use a point-based surface generation, and it's going to measure it off of the box itself. So the cool thing about this bounding box is that it actually creates a box, and we can measure the dimensions of that box and then use that in order to generate a new one in a new location, wherever we define it to be. So so let's start to work down that road. It may get a little messy trying to connect it back here, but bear with me. I think I will copy this last one here, and I'm going to move it sort of off to the side over here, and I'll change the group color. Just so you can see that there's a difference between these two. And I won't need all parts of this. I won't need all parts of this, and it may kind of Frankenstein into something else. But basically, the important thing that I want right now is this bounding box. So the bounding box down here actually allows me to measure the height and width and length of that box. If I go to Surface and Analysis, I can go here to Dimensions. Actually, there's a box version of Dimensions. Hang on. Size domains. I don't know if I want domains. Evaluate box. Box properties. I think it's box properties. I'm starting to forget which one actually does this. So we have center point of the box, the diagonal vector of the box, the area, volume, and no, that's not the one I want. XYZ, no, there's a better way of doing that, I think. Well, all right. Let's do it this way. I'm going to deconstruct this box. So I'm going to go to deconstruct BREP, and I should be able to plug that in and grab the individual faces. And so with that, I'm going to list item and grab certain faces that I can use to measure. So those will just give me a numerical value. So I'll go to set, list, and list item, and I'll grab faces. 0 to 5, because this is a box, so there are 6 sides. So item 0 shows me the width and the height, and that's fine. I could use that one. That's no problem. And then if I go to this one, I can extrapolate the depth. Okay, so that should serve my purposes right there just fine. I have all 3 axes within that. So let's go back up to surface and analysis, and let's do the dimensions of a surface. So I'll plug this in, and what I get is a numerical value of 0.25 and a value of 0.5. So that means it's 6 inches wide, and it's 3 inches wide, and it's 6 inches tall. And then here we have the 0.45833, which is the depth, and then we should have 0.5, which is the height again. So we need our UV here and then our U there. So here's something I'm going to do to help us understand what's what, I'm going to go back into params. I'm going to go to primitive, and I'm going to grab a number. This is the first time I think we're using the number primitive. And it's just a way for me to provide an extension onto these that have a different title. It makes it a little bit more clear for me. So on this one, I'm going to call this number my width. And I'll call this one my height. And I'll call this one either the depth or length. Okay, so that sort of gets me started. And so now what I'm tasked with doing is figuring out how I'm actually going to locate the geometry. Okay, so I'm going to have to create a surface that matches the depth and the width. And that surface is going to be mapped onto, well, it might be the depth or the width, or yeah, it could also be the depth and height. Not the depth and height. It could also be the width and height. But it depends on whether or not we want to map the location to the surface or if we want to map the location based off of the fin. Okay, so that part is kind of up to you guys to figure out, and it also depends on how you've constructed the actual geometry. In this case, because it's flat, it works. When you're doing a warped surface, you might have to do this for every single one of the various components. So for instance, you might need to locate this on the glass and then locate this on the fin, and then similarly locate this to morph between the two. Okay, so that, I just want to throw that out there as a more complex exercise. This is like your first step, your intro level of doing this. Okay, so let's get back to it here. I'm going to use the surface itself. Okay, so the surface I think is going to be the way that I'm going to start generating this. Let's see, do I want to do it point based? Probably want to do it point based. Well, let's kind of start off this way. Okay, so I'm going to do a non, no, I don't want to do it that way. Hang on, let me think this through. All right, so here's how I'm going to do this, guys. I'm going to do some sort of layered domains that are going to basically extrude my surface, essentially. And it is going to be a point and then a line and then a plane that generates it in all cases. Yeah. Let's do it that way. So we'll start off with the first one. The first one, I need to go back to my original subdivided datum surface. So that's going to be this one right here. And I need to deconstruct it. And then from that, we're going to list item for each of the panel's vertices to grab one of them. So I'll go to set, list, and list item, put the vertices in, and then slider from 0 to 3. So the 0 item is the top right corner of the panels. You can see that here, top right corner. And if you go up there, you'll see top right corner. It might be a good time for us to turn off these morphs. I'm going to turn off all these existing ones. There we go. All right, so top right corner. This is how this one's going to work. Okay, so I'm going to yeah, there might be a smarter way to do this. I'm going to do this the dumb way, the first way that I can think of first, and then maybe we can make it a little better. So I'm going to move it a certain value down across the panel. And then I'm going to move it off from the edge. So it's basically like an offset exercise. Yeah, basically an offset exercise. Actually, oh, there are so many different ways we could do this. I think what I want to do is the edges, now that I'm thinking about it. Yeah, I'm going to do the edge. Oops. No, I changed my mind. Go back to the vertices. All right. So we're going to have to find that surface normal again. So let's go back here and grab our surface normal tool that we generated. And that's going to be on each of these surfaces. And the reason that I grabbed the surface normal is because I can align a plane to it. So if you go up to vector and plane, I want you to create a plane perpendicular to a vector. And so for us, that's going to be the normal, which didn't work. Oh, whoops, sorry. So you're going to use the normal as the location, and then you're also going to use, the centroid as the location. Sorry, there you go. And then the normal as the direction. Oh, and of course, it's giving me these weird things. Oh, hang on.